We are back here with Matheus Castello and Fernando Rolnik to show now Blazor, the new .NET Blazor framework running inside the IoT device. And don't forget to subscribe the Azureta YouTube channel where we are sharing a lot of videos. We have videos from Matheus, Nuno, Fernando, a lot of community members. Please subscribe.
And also subscribe Micro Hobby, the Matheus channel.
Yeah, Micro Hobby is a nice blog from Matheus. We're going to put the link here. Matheus has a channel as well. Please subscribe his channel. Has great videos about Windows subsystem for Linux and embedded systems.
Embedded Linux, yeah.
Yeah, Linux. Matheus, all yours. What you have for us today?
Let me share here the screen. Here I am the Toradex device, embedded Linux, right? I will show a bit more details later, the specs of this device. Here I have connected two LEDs on blue and yellow LED on my GPIOs of my device, right? And a button for use a pin as input. The LEDs I will use as output. And also I have here a sensor, a light sensor. And here on the screen, we can see the Blazor already running. Okay, let me make the light, the brightness a bit lower here. And here on the screen is Blazor running, right? And here I have the components, the HTML components. And if I click the buttons here on the screen, I have the LEDs being activated, turn on and turn off when I press the buttons, right?
Cool.
The same thing, I have here the input of my light sensor, right? So I have here this DotNet component. If I put the finger here, you can see that my environment is with lower light. So you can see the level decreasing on the component. If I have more light, also I can put the flash of my smartphone here and we can see the increase of the light on the sensor. So all of this I'm using the .NET IoT project using C# and also the Blazor to make the user interface.
That sounds great, Matheus. I think anyone can using like a Toradex board there.
Yeah, let me show here the board that I am using. This is the Apolis IMX6. Is a quad core. We have the Apolis quad core and dual, but in my case here I'm using the quad processor. Apolis IMX6 is a quad Cortex A9 ARM Cortex processor. We have 4 GB of memory RAM and 4 GB of MMC flash, right? And as you are seeing here, we have a computer modeling, right? This appears a memory modeling, right? That you use in your old PCs or in the notebooks that you have the memory model, the RAM memory model. But here we have all these features, the processor, the memory, and everything that you need to use the interfaces and connect this in a carry board. What I'm using here, I connect this. Let me increase the light here. And as you can see here, I have the model here, right? This is connected in what we call a carrier board, right? So the carrier board that implements the interfaces, right, that we have in our computer modeling, right? This is hard to project. The design of this, the PCB of this is high clock. You have to spend more time to build this kind of.
Matheus, can you tell us like a real life product that's using this board, like in real life, is embedded in some product these days, or?
Yeah, we have the cases of the lung ventilators. We have some customers that use this in lung ventilators because these have a microprocessor, the ARM Cortex for the UI part and everything, and also have M Cortex, the microprocessors, the microcontrollers, processors of the ARM. So we can have the control, the controls of the lung ventilators inside the ARM and out the UI part and the rest on the Cortex A.
I think the message is if someone want to learn the IoT edge, IoT, SDK and library and play with device is a market that's growing. There's a lot of market to work on with device, and that's becoming easier and easier. Show us how you did that code, and looks like using an extension for Visual Studio Code.
We have a lot of documentation about this extension already, right? But this is, for now, this is working only on Toradex hardware. We are thinking also to open it to Raspberry Pis. So this will be more easy to use it also in the maker applications, okay? For now, it's only for Toradex hardware, but soon this will.
What the extension is doing, the extension is helping you to package your application that you're developing on Visual Studio Code inside a Docker container that will be deployed on your device, and then you're going to be debugging from Visual Studio. That picture is amazing because it's exactly what I'm saying. Yeah. Then you're going to deploy your application and you're going to start debugging inside your device. And the extension is helping to automate this.
Exactly, because when we have an embedded device, we know that we don't have all the power of the processor and all the power of the RAM memory that we have in your development PC. So you can use your development PC to develop your application, your IoT application, your embedded device, your embedded Linux application. And using your development PC and the Visual Studio Code, you can connect to the device and make this deploy using Docker. And the extension will do this automatically for you and pack the Docker image with your application and connect to the remote debugger.
Great.
Okay, so another image that I want to show is this one. As you see here, I have the screen that I show, right? That I'm calling here a local UI, a local user interface. This is connected via HDMI on my device, right? And on my device, I'm running Horizon, the operation system that runs Docker runtime. Is the only thing that is running on the Horizon, the Docker runtime. And inside the Docker runtime, we have the containers that is the applications, right? I have a video renderer, a video compositor, the Wayland Weston, and this is showing my Chromium that is opening my application that is a Blazor Server application, right? And I can access this application on my local UI because this is connected on my device, and also I can connect it in a remote UI if I open a browser and type the IP address of the device. I can access the same thing that I'm seeing on the local UI. I can see on the remote UI. I can exemplify this after. Other thing that I can I have to show also is this, because for the Blazor today we have two ways to make application. We have the Blazor WebAssembly and the Blazor Server, right? For embedded devices and IoT, the best way is use the server mode, the Blazor server mode, okay? Because as I'm showing here, when we have, in this side here, we have the Blazor WebAssembly, right? The Blazor WebAssembly will compile your application, your DLLs, your binaries for run in a .NET runtime that is running in WebAssembly. And this have access, this is a sandbox inside the browser, right? You don't have access to the peripherals or, for example, the GPIOs that I want to use. So if I want to make a connection to the GPIOs or sensors, we will have to make other calls or a REST API, for example, using the WebAssembly mode, because this is a sandbox. By security designs, right? We have this. And on the server side, this is cool. Use the servers in server mode onto the embedded device, because the server is the device itself, right? We don't have the server in a cloud. The device itself is our server. So all the calls that the browser or Chromium right here, that this Chromium here, all the calls that this Chromium are making is for the device itself, okay? So
it's from the container that runs the server, right? We have a 2 tiers application. We have the front end that runs this container, and we have the back end applications that connects to the GPIO, and we use the REST API to talk with the back end, right?
Exactly. And I don't need a REST API because the Blazor makes these calls very transparent. I will show it. I will show the code. I will show the code and you will understand. For example, here on my index page, the index page is this. We have the HTML and also the code. This is C#, right? This is C#. Yep. This code block here, we can write this code block inside the HTML and make the binds here. For example, the LED blue color, the LED blue power here, all these are variables inside the code block. This is C#, right? And I'm making the binds here on the HTML. So if these variables you change the state, this will also be mirrored on these binds here on the HTML, right? So this is very cool because I can make all the logic of my user interface and also receive, for example, I have here this unnotified data changes that these functions are received from the changes on the hardware, okay? So I'm using the libraries from the last video, right? And these have these dispatches of the events, okay? So I can use this here to check the changes on the hardware and make the changes on the screen, okay?
Okay.
So I have another example here that this can be more clear. Let me show here. I have the data razor page. The data razor page is a more common example that we have on Blazor use, because we have a button on the screen. Let me show in. Well, where is the here? So let me. I have here another page, right? This data page, okay? And I have here a button, click me. This is a common a demo from Blazor that shows the changes of the variables, right? This variable and this button. Let me show the code here. So the button is a HTML button, okay? But the on click, I'm binding a C# function, the increment count. And on the p tag here, I current count and binding, and I am binding the variable, the current count. So if I increment the current count here, this will be reactive and will show this changing on the screen. But also, I have here our button, right? Remembering the button here? So using the .NET GPIO libraries, I can make also, here I have a virtual button, here I have a
physical button.
Physical button. So if I click, I'm clicking here the button. If I click here the button, this will increment also the variable, because I'm receiving here this on push button preset from the hardware, right? And I'm also incrementing my current count, and this is being reactive here on the user interface.
And this button is coming from a GPIO input. As we showed in the last video, we introduced the GPIO on the .NET. We have an input. Can you show for us when?
Yeah. Here on the Blazor, as we can open this as remote UI and local UI, we have these services that we call services. Okay, so here on the Blazor services, I'm adding a singleton, right? So the same button, the same resource of the button will be used in all the sessions that will be connected on this Blazor server that is the device. Okay, so we have only one button. This makes sense. Have only one reference to the button. Okay, so is what I'm doing here. So I have this GPIO device service class. Okay, so I'm defining here the lines that I'm using for the buttons and LEDs. Okay, I put everything that calls GPIO. I'm putting inside the GPIO device service. Okay, so I have here the line 7. That is my button, red pin, right? And where is the here? So the same thing that we have on the last video, right? I'm opening the GPIO bank. I'm getting a reference to GPIO controller, and here I'm opening the pins as output, these the LEDs, right? I need as output, but the button I need as input, right? And another thing that's very cool, because the .NET IoT already have this register callback for pin value change event. It's a bit big name for a method, but is really what the method does, right? He registers callback and waits for the value of the pin change, and this trigger or notify push button preset that will be handled by the data eraser here.
Oh, so this is like a seamless integration between your embed device and the interface. It's very cool.
You don't need to make a pull for the changes, right? You already have a method to check this for you, right?
Okay,
so this will be called only when we have a value change.
Cool.
I think in .NET, Fernando, we say, we are listening like an event, and every time that we receive that event, we're going to trigger another one that will be, the screen to increment the count on the screen itself. You could even trigger multiple things. It's just triggering one, but you could trigger multiple things. I think it's a notification, that's on Marshall on .NET using events. It's amazing. I think it's very easy to be done, and I'm assuming that you're going to share this code. And
yeah, I can put on my GitHub. I don't put this yet on my GitHub, but I can put and share with you guys.
Thanks. I think it'll be nice for people to learn, and if you want to play with Toradex boards or like you said, if you guys are going to go for Raspberry, it's good for people to learn and then get more professionals and people learning how to do, embedded systems and a big market.
And here I'm using Toradex because I have access to this hardware and then work for Toradex. And for me, it's more easy to make on Toradex, but this also works on Raspberry Pi. If you change here to GPIO device service, the references here to the pins for your Raspberry Pi, this will works for sure.
Oh, it's awesome. Actually, now I'm interested in learn .NET, because so far I'm coding embedded device only in Python. I have this challenge to build like a user interface in JavaScript, but like it's too much complicated in using like Python as back end and JavaScript as a front end, but it looks like easier to use this Blazor.
Yeah, it's very, because you have the Blazor is a way that you use C# as JavaScript. So you are using here the C# as JavaScript to increment and make the changes in the HTML. This is very transparent because this all, as I show here on the PowerPoint, this is this signal RR codes, right? That you have in the browser and the application, but this for the developer is transparent. You are not seeing these codes. You are writing C# and making bindings in HTML. Behind scenes, don't matter.
Yeah, that's the amazing thing of .NET. You're trying to abstract things and make things easier for the developers. Matheus, if anyone wanna learn more, follow what Matheus is doing on that. Micro Hobby going to put his YouTube channel here as well. You just click on the top and follow him, and we're going to be recording more videos for sure. And thanks for sharing. And
activate the notifications from the Azure Arteiro channel. We'll have more videos with embedded device, Docker, containers, Kubernetes, etc. Right?
Yes, and thanks Toradex for letting Matheus to share and share all this content with us. Thank you.
Thank you, Matheus.
Thank you, guys.
Thank you. Bye-bye.
Bye-bye.